So let's begin looking at integration by using a table with this one. So notice that we have a cosine of something. We have something out front. So let's take a look at our table to see what formulas we have that maybe involve a trig function or something. So if we go to the ebook and go to Appendix B, the integration table, then we want to scroll through until we get to some that involve a trig function, that involve cosine. So I'm going through, flipping through, and okay, I see some that have cosine in them. So here, I see one that has 1 plus or minus cosine u on it. So this looks close. I have a 1 minus cosine u, but I also have this extra thing out front. Well, just out of curiosity, let's see what's going to happen if u is the square root of x, which square root of x is x to the 1/2. That would make du 1/2 x to the negative 1/2 dx, or 1 over 2 square roots of x dx. So really, that square root of x is part of our du. We actually need a 2 to go with that on bottom and a 2 to go on top out front. We can also pull that 7 out front as well. The integral of, let's group it like this. If we pull the 7 out front, we just have a 1. Then we have 1 minus cosine square root of x. And then let's put the dx over the 2 square root of x's on the end. So pull the 7 out front, leaving us a 1. We have 2 square roots of x there. So what we have is 1 over 1 minus cosine u, and all of that's du. So the table tells us what that integrates into. If we have 1 over 1 minus cosine u, that integrates into minus cotangent. If we're using the minus here, we use the minus there, so minus cosecant plus c. So we have 14 out front minus cotangent of u minus cosecant of u plus c. And on the test, I'm going to ask you which formula you use, so that's formula 57. So that's using number 57. So that one's kind of a rough one to start with because we had something out here that actually ended up being part of our du. But it came from recognizing that a big part of this is a 1 minus cosine. All right, let's take a look at the next one. This homework problem actually asks us to do it with a table and then also to do it by parts. But let's just look at doing it with a table. So if we look through, we have, this one has an e to the x in it. I don't think we've gotten to the e to the x's yet. I could be wrong. Okay, here are e to the powers. So ours resembles 83. So let's see about copying that formula. So let's cut through here. Oops. So we're similar to this. We're a little bit different, but we're similar. So if we're going to look like this, e to the u is going to have to be 11x, which means du is going to be 11 dx. Now wait a minute. This is u to a power That is not u. But we could make that u. We could make that 11. So that this would be u and that would match. Notice if we were to square this, that would give us x squared. Also picking up not just 11, but 11 squared. 11 squared times x. We can pick up an 11 squared. There, we have to pick up an 11 squared on bottom there. Also, our du is 11 dx. So if we pick up an 11 there to go with dx, that's on top, we would have to pick up another 11 on bottom out front. So we picked up an 11 squared on top here, so an 11 squared bottom there. 11 on top here, so 11 there. So we really picked up 11 to the third power. So what is 11 to the third power? 1,000. And then that's u to the second, e to the u, du. So this tells us what that makes. That equals, we have our 1331 out front, and when we integrate u squared e to the u, that's u to the n. Our n is 2. E to the u minus n times the integral of u to the 1 less power, e to the u du. Then eventually plus c. So we're going to come back and we're going to put in our u's here later. But now we need to know, well, how do we do that? So let's copy down the integral we've already done. You've got u squared e to the u minus twice whatever we get for that. So if we integrate u e to the u, that's u minus 1 e to the u. U e to the u, that's u minus 1 e to the u. And then we have our plus c on the end. Our u is 11x. So we have our 1331 on bottom. We have 11x squared. And I tell you, we could factor this first before we substitute in. Let's do some distributing, and then we'll pull out what we have in common if that simplifies any. Actually, let's do this. We have an e to the u in this term, and then this term has an e to the u. So we can pull an e to the u out. If we take an e to the u out here, we're left with u squared. If we take a e to the u out here, we're left with negative 2u plus 2. Let's call this e to the 11x over 1331 times u squared, so 11x squared minus 2 times 11x plus 2, and then we have a plus c on the outside. So that's from using two formulas, actually, number 83 and 82. 83 first, because we had u to a power e to the u, and then once we integrated that, then we had u to the first. If we integrate using u to the first e to the u, that's that one, 82. And then we go back to u back in again. Okay. Well, what about this one? We did a section on integration by parts, but how, or not by parts, but partial fractions and splitting that up, how can we do it without it? So let's go back and let's look at some, see if we can find a formula that fits this. So this parenthesis, this is not a u squared, that's just something to the first. So it's probably not going to be in the a squared u squared section. But what about this? We have a u to the first and then a constant. A u to the first and a constant. If u is x, notice this one has u to a power out front. So let's see if we can make it fit 18. So let's cut that here, let's paste it, and see if we can make ours look like that. So if it's going to fit this one, u is going to be x, which would make du dx. N is 2. A, that's a constant, so our constant is -1. B is the coefficient of u. If u is x, then that's bu, so the coefficient of x is 1. So yes, that's what we have. We have 1 du. This is bu, and that's a, where a is -1. So we're told that that integrates into -1 over a times n minus 1 bracket the square root of a plus bu. Well, that whole thing is a u, so we could call that x minus 1 over u to the n, so 2 minus 1 power plus, let's go ahead and multiply that out. 2 times n, so 4 minus 3, so 1 b. B is 1 over 2 times the integral of 1 u to the n, so 2 minus 1, square root of, and I'll tell you what, let's be careful here. That was x, and that was x minus 1. And then plus c on the n. So we went ahead and substituted in for that whole formula. Now, those cancel. 2 minus 1 is 1, so all of that's 1. So we have the square root of x minus 1 over x plus 1/2 times whatever we get for that. And that integral is that where we have u to the first power. U to the first. So we could get away with using 18 again, or if we do the one where this like 18 where u is to the first, we could do 17. So cut that. That here. I'll move that in a minute. So our u, our a, our b, bu, all that's the same as it was before. Our u is x, our a is -1, our b is 1. We've got all that. So since our a is -1, we're using the bottom version. Since our a is -1, we're using that one. So that integrates into 2 over the square root of -a, which is negative, a is -1, arctan of the square root of a plus bu, which is x minus 1, over negative a, and then our plus c. So just using that bottom formula, plugging in our a plus bu in there. So if we simplify this, we have the square root of x minus 1 over x. Those cancel. That makes 1. So all of that's 1. Arctangent of the square root of that's 1. So x minus 1 plus c. So just recognizing which formulas we're using. This time we use 18 and then 17. Still took a little bit of work, but it was just recognizing which formula, what is our a, b, u, and n. So once we knew a, b, u, and n, we plugged into here. Notice we can't use this one if n equals 1. So when we got to this integral, then we were down to n equals 1. So if the power of u is 1, we had to use this one. So which version of this do we use? That depends on what a is. All right. Okay, let's take a look at this one. So we have a radical. We have a variable to the second power here. So sometimes these can be tricky. Here, let's see. We have a plus, so it's not this one. And let's see. This one involves the square root of u squared plus a squared. Keeping in mind that since this is adding, we can rewrite this. Oops. We can change this around as 25x squared plus 6. So in this case, if we call this u squared plus a squared, then u would be 5x, du would be 5dx, and if a squared is 6, a is the square root of 6. So we need du to have a 5 with it, so 1/5 out front. So if this is u squared plus a squared, looking at our formulas, u squared plus a squared, then one formula has a u squared out front. So we would want this to be u squared. U is 5x. U squared is 25x squared. So this needs 25 with it so that it's u squared. Well, if we pick up a 25 there, we have to pick up a 25 on bottom. 175. 25x squared, that was our u squared. That's our u squared, a squared, and that's du. So, as we mentioned in a previous video or in one of our conferences, it's very important that we make good notation about what is our u, what's du, what are we substituting in for. So if we think that this is going to be a u squared plus a squared under the square root, that's what we're trying to use. a square root of u squared plus a squared under the square root, then u squared is 25x squared. That lets us know u du. Well, a squared is this, so that makes a this. Well, if this needs to be du, we need a 5 and a 5 here. If this needs to be u squared, that needs a 25 with it, so we have to pick a 25 up there. And that's not 75, that's 125. So we have 1 over 125, and the table tells us this is number 27 in the table. The table tells us that integrates into 1 over 8 times u times 2 times u squared plus or minus. So we got a plus, so we're going to do plus a squared times the square root of u squared plus a squared minus a to the fourth. Well, if a squared is 6, a to the fourth is 36. Natural log absolute value of u plus the square root of u squared plus a squared. And then that's plus c. So I guess we can cut that. Oops. So since we determined it was this formula, then we already had the 1 over 125 out front. Then we had 1/8 u 2 u squared plus a squared square root minus a to the fourth natural log of absolute value, and then just plug in. So we could simplify that a little bit. That's going to be 1 over 1,000. We're going to have a 5x. In that parenthesis, we're going to have 50 x squared plus 6 square roots of 25 x squared plus 6 minus 36 natural log absolute value of 5x plus square root of 25 x squared plus 6 plus c. So even if we tried to do this with some integration technique, we don't really have a good obvious substitution to do this one. Integration by parts would be messy. It would take us a while to get to something that we could really work with here. So the table makes this better. It gives us a formula for something in this format. We just have to figure out which formula are we using and then how to make our substitutions. All right, let's take a look at this one. If we try to look at ones that have natural log in them, I suspect we're not going to find one that fits this formula. If we have one that has, there's one that has e to the u's. Notice if we look at the ones involving natural log, well, we don't have one with a fraction like that. But notice those things are the same. And we have one of them on top, one of them on bottom. So let's keep that in mind as we go back through some of this list. It's not under a square root, so it's not those. It's not something squared, so it's not those. Not under a radical. Not squared. But what about this? Could it be in the form something a plus bu? If this is a plus bu, a is 7, b is 3, u is natural log. If u is natural log, du is the derivative of that, which is 1 over x dx. So look what we have. We have natural log on top. Let's forget that part for a second. We have 7a plus bu on bottom. And that x, we could move over there, and that's our du. So we essentially have u over a plus bu. So u over a plus bu, that's number 3. So that's this one. So that integrates into 1 over b squared, so 9, times bu minus a natural log absolute value of a plus bu plus c. And that just comes from using number 3. So sometimes the formula is hidden a little bit. We saw natural log, so we tried to find a natural log, but this wasn't a natural log. It was actually an a plus bu. Right. For time's sake, we'll stop on that one. But here, it looks like we have an a plus bu again. So there's some that involve an a plus bu squared. So we might have to do a fit there.